Okay, the cofunction of sine is cosine. That's where that's why it has co in front of sine. So that's a definition of cofunction. Sine and cosine are cofunctions of each other. The cofunction of secant, well, that would be cosecant. That's why you have co in front of secant. They're cofunctions of each other. So you're going to pick this one. Now, here's what it means to be a cofunction. The cofunction of cosecant is going to be secant. But the reason they're called cofunctions is because they are related to each other in this way. This is angle A, that's angle B. A and B are complementary. That means A plus B is 90 degrees. Okay, we know that because this is 90, C is 90, and that means A and B have to equal 90 since triangles total 180. Well, guess what? The cosecant of A is the same as the secant of B. And guess what? A and B, well, if A is 90 minus theta, then B is theta. Okay? So these two angles are complementary. And if they're complementary, then their cofunctions are equal to each other. Okay? I'll give you another example and we'll make it more specific. Tangent of 90 minus theta. So tangent of A, this is B, but tangent of A is what? It's opposite over adjacent. Okay, but watch this. Cotangent of B is what? It's adjacent over opposite. Exact same sides. Exact same sides. So the ratios are going to be the same. So, and A and B, A plus B is 90. And so A is 90 minus B. B is 90 minus A. Okay? So when they're asking about, when you see something here written as a, signaling as a complementary function, take the cotan of theta and say, be confident that they are the same. They're going to be the same ratio. All right, so this you need a little background knowledge. You're going to have to accept as we move toward the coordinate plane. Okay, this is the coordinate, whoops. This is the coordinate plane. Y-axis, x-axis. As we move toward analyzing triangles, we're going to move those ratios into the coordinate plane. And what you're going to have to accept is that sine is associated with y, and cosine is associated with x. Okay? And tan is associated with, is really defined as sine over cosine, which now we know is associated, x is related to cosine, y is related to sine, and that's really what tan is going to be defined as. Just the way sine is defined as the y value, cos is the x value. You'll see that later, but for now, just accept that everything is going to be defined just in the coordinate plane in terms of y and x. And y is related to sine, and x is related to cosine. So we're even going to build our reciprocal functions, which I'll do in blue, out of sine and cosine. And we're going to pause on defining them as adjacent or over opposite and hypotenuse and whatnot. Okay, so cosecant is 1 over sine, which makes it like 1 over y. Secant, secant is like 1 over cosine, which makes it like 1 over x. And cotan, you guessed it, is going to be, well, it's, oh, I should have said the upside down, the reciprocal of tan, but that just means you flip over the tan. 1 over tan, which means it's tan flipped over, which means it's cosine over sine, which means that is x over y. Everything is going to be defined in terms of sine and cosine, which means everything's going to be related to x and y. And that way, we translate everything into this world, where really everything, it can be defined by x and y. Okay, so the whole point of this is that sine values, the sine ratio has a sign. All these ratios have a sign, and I'm going to say sign this way. Sign meaning, oops, with the G, sign. I tried to make that in bold. Meaning it's going to be positive or negative. Okay? Everything is going to have a sign. So it depends on the angle. I'm going to say specifically the rotation and where the ray points to. So you have an angle. Let's just put it here. I don't know what number, what size of that angle is. I know it's between 180 and 270. But if they're asking about, let's say, the cosecant, let's call it cosecant of this, I'm going to just guess maybe it's 210. Okay? You have to do this translation where you say, hey, this is related to sine, which means it's related to y, and whether or not y is on top or on the bottom, it doesn't matter. Y, whether it's here or here, the y values are negative down here. They're negative down here. So I know cosecant of 210 is going to be negative, just by virtue of the definition. Again, think about sine, think about y, and then think about these two quadrants having negative, where y is negative, down here. Okay? I'm going to do something. If you have an angle or rotation here, this goes all the way around. This between 270 and 360, let's just call it like, I don't know, let's call it 310. Okay? So let's pick something that involves cosine. Secant. Or cosine itself. Let's pick cosine. That involves x. What's cosine of 310? I don't know exactly, You got to put in the calculator for that, but I know the calculator is going to give me a positive result. Why? Because cosine has to do with x, and x is positive all up in here. I'll do it in purple. This is where x is positive, right? And remember, these quadrants have Roman numerals. So cosine is positive in quadrants 1 and 4. Right? So this is the translation to the coordinate plane. All right, so let's go back to delta math. Where is tan negative and where is cosine also negative? What quadrant are they? Is this for where these are both true? Well, let's do tan is negative where? Tan is a combination of, it's a fraction, a ratio made of x and y, right? Sine over cosine, x over y. And these are both positive. When these are both positive, tan is positive here. But when one of them is negative, and over here in quadrant 2, the cosine is going to be negative. So you're going to have positive over negative, which results in negative. So tan is going to be negative here. And guess what? Because here you have both x and y being negative, tan is going to be positive here. And tan is, I should have a different color, but tan is going to be negative here because the y value is negative and the x value, or the cosine, is positive. So here, these two quadrants, you've got tan is negative. Well, where is cosine negative? Where is cosine negative? Cosine is negative here, because cosine is related to x, and x is negative there. So which quadrant have I shaded 2 times? This quadrant. And that's quadrant 2. Because that's where both things are true. That's where both things are true. Okay. I'm going to do this one a little quicker. Secant is negative. Secant is related to cosine. Cosine is negative here. Okay. Cotan is that combination. So you want the quadrants where you have different signs for x and y. Okay. And that would be, different signs would be here and here. So therefore, the overlapping quadrant is quadrant 2 again. Okay. Express this as a function of a positive acute angle. What's a positive acute angle? It is a reference angle. Okay, because reference angles are all 90 and below. Well, you can even call 90 an angle. Well, maybe you can. Yeah, actually, it's true. So sine of 222, well, you know where 222 is. It's going to be somewhere between here and here. And let's just pretend it's like thereabouts. Sine of this angle is going to be, oops, it's going to be a ratio of opposite of this angle to the hypotenuse. Okay? But this angle right here, what is that angle? Well, this was 222. So the difference between 222 and 180 is 42, right? Between here and here is 42. So, if we put a 42 angle right here, the ratio of the opposite to hypotenuse is the same as this opposite to that hypotenuse. It honestly doesn't matter kind of like how far out you draw that triangle, how big the ratio. The triangles are all going to be similar. Okay, they're going to be equivalent triangles. If you do it out here, do it in here, but the ratio is going to be the same. Sine 42, sine 222, they're going to be the same ratio. But the difference is, because we're now working in the coordinate plane, sine of 222, because it has to do with y, is going to be negative. Okay? So you'll see, when you put this into the calculator, you will not just get the ratio of this side to that side, which in terms of lengths, it's going to be they're both positive. You can't have a negative length. But when you translate into the world of coordinate planes, the sine value affiliated with y is going to have a sign. It's going to be positive or negative. And you got to use what we just talked about. Your knowledge of sine goes with y, goes with negative in quadrants 3 and 4. Okay, so how do you do that? Well, first get the ratio out of it. They only want you to use positive acute angles. Fine, let's use 42, because we know that's going to have it's based on the same triangle, sine of 42, but got to make it negative. Then it will be equivalent to sine of 222, because it will have the ratio, but it will also have the sign. Negative sine of 42. Let's see how Delta describes it. Sine 222 is negative, just like we said. 222 is quadrant 3. Okay, so this is a little mnemonic that you can look up. You can Google this if this helps you. Sine of 222 is the same. See these ratios, 0.669. Triangle-wise, they're going to have the same kind of like comparison between opposite and hypotenuse, except sine of 222 is going to be negative. Just the way if you had a positive ratio, you make it negative. They're going to be the same. Same value. Okay? Try this. Sine of negative 19. Sine of negative 19. So where are we? We're down here a little bit, because you go in the opposite direction for negative angles. That's negative 19. Well, the reference angle, this distance is obviously 19. So I could do the same thing up here. That's 19. Okay? So you want the sine, you want to compare some opposite length over the hypotenuse. That's great. You can do it by saying sine of 19. But negative 19 degrees right here, this ray is in quadrant 4. Sine is negative here. So go ahead and slap that there, and you'll take care of it. Okay.